Welcome to the Works Plus TechTalk podcast. Today we are welcoming back our very special guest, Peter Killeen from Concrete Methods. Today we're going to be talking about low carbon concrete. Is it feasible or is it fantasy? Some of the things we're going to be covering is how is low carbon concrete made? How is the market in Australia currently poised for this? What are some of the low hanging fruits? And Peter's actually going to talk to us about something that I don't know I've ever heard anyone else talking about. So stay tuned and listen for that. Let's get into it. Hello everybody, and today we are joined once again with Peter from Concrete Methods. Peter Killeen, thanks for joining us again on the show.
Thanks for having me.
Today we're talking about something that might be controversial, might not be. So we're talking about sustainable concrete. Is this a feasible thing or is it fantasy?
It's feasible, but.
All right. Well, I guess we'll be talking about a whole lot of the buts today. Sustainable concrete. What's the vision?
The drive in our world is to reduce the amount of carbon that we produce, and cement produces a lot of carbon, crushing rock produces carbon, digging sand out of the ground produces carbon, transporting it to the job site produces carbon. So there's all these CO2 issues that are around it, and cement does create and use a lot of energy and create a lot of carbon when it's being manufactured.
Sure.
So the drive for the concrete industry is to reduce the amount of cement. That's the primary one, is reduce the amount of cement that's used in the concrete.
Gotcha.
And to do that, we would use supplementary cementitious materials that we all refer to as SCMs because the concrete industry loves acronyms. And those materials mostly are slag and fly ash.
Gotcha.
So slag is created from grinding ground blast furnace slag from making iron or steel, and slag is fly ash is the ash that's produced when you burn coal. So it's mostly captured from coal-fired power stations, and it's captured off the chimney, and it used to just go into a big hole in the ground, and now we use it for putting into concrete. So start with each one of them. They react in a different way. So fly ash reacts with lime, and the lime comes out of the cement after it's reacted with water. And cement and water react to make a compound called calcium silicate hydrate, and then lime will react with the fly ash in the presence of water to make more calcium silicate hydrate. So it makes a more dense and durable concrete, and it'll have a higher strength, compressive strength, and even a flexural strength development after the 28 days that we normally measure concrete strengths on. It'll increase strength more than if it was a full GP mix. So there are benefits to using it for the concrete and the durability, but in small doses.
In small doses. Do we have small doses for the foreseeable future? Because it seems to be a little bit reliant on the generation of some other things that we're trying to shut down.
It does. So we're trying to stop burning coal for making electricity. So where eventually is the fly ash going to come from? At the moment, there are a lot of stockpiles.
Yep.
But eventually those stockpiles are going to go. So what else can we replace cement with? That's a longer term discussion. The slag, it operates differently. So we grind up the slag from the blast furnace. We make it into a powder that has the same consistency of cement and put it in. And it reacts with alkali. So when it's in an alkali environment, it'll react and it'll do its thing. I can't tell you any more detail than that. That's as far as my chemistry goes.
Yep.
But when you reduce the cement from the concrete, you're also effectively reducing the pH of the concrete. You're reducing the alkali content. And so when we go to high doses of slag, we need it to go off in a reasonable period of time, not take forever to go. And so some of the concrete suppliers are looking to use an additive to put in, which is effectively an alkali material. So for the sake of it, something like caustic soda, a refined version of caustic soda, is the type of thing to put in to increase the alkali and get the slag to kick.
Yeah, right.
Now, at the moment, most of the concrete suppliers are using more cement than they really need to make strengths because they feel like they're going to be crucified on projects if they get a low strength. So they all use more cement than they really need to. And the Green Building Council has put in a benchmark for the amount of cement that you're supposed to save against, which is a bit ridiculous. You don't really need to use any SCMs in order to, if you just simply cut the cement content back to what's reasonable.
Okay, so what is the Green Council calling for then? What are the metrics that they're shooting for and what are the timeframes?
Well, at the moment, most of the consultants are telling us we need to use 20% replacement. 20% is not really that big a deal. We've had more than 20% replacement for many decades already, but the concreters who have to finish the concrete don't like 20% because it takes longer to set. And so now you have to offset that with some accelerator. And that's not just as easy as putting an accelerator in and making it go off faster. You change the performance characteristics of the concrete at the same time. So it's not always the right thing to do. The other things that we see is the concrete suppliers have to make strength, and they get the opportunity to cure the concrete perfectly in a water tank at 23 degrees for 28 days. We can't replicate that level of curing in the field, particularly with elements that are finished or what we call unformed surfaces. You have to finish with a trowel.
Yeah.
Now, in a column, a beam, a wall, or a footing, it's easy. They're mass. And you can tip that stuff in there, and when it gets hard enough to put the next element on it, you can. Now, in a footing, you might want it to go a bit quicker because you want to stand the column. But for everything else, it's pretty much going to make strength in the time that you want it to. When we do unformed surfaces, we now need to get some durability into that surface. And so the higher proportion of supplementary materials might not be conducive to the hard wearing that we're looking for at the surface.
Yeah, that's right.
Most of the work I do is in industrial, so we're looking for that for a forklift not to wear out the surface. For your customers, they're looking to get obviously a hard wearing surface, but you've got to polish it. It needs to be hard enough, have enough strength. So the supplementaries might eventually be causing difficulty with that in getting to achieve it. And so the biggest problems that we're seeing on unformed surfaces is durability.
Yeah.
How do we make them durable? So looking forward, what we're thinking is the use of a densifier that targets the particular characteristics of the fly ash needing to have some lime to react with, and for this the slag to be able to have some possibly a higher alkali content to act as an activator to make it kick. Maybe those things is where the densifier needs to be targeting.
And at what stage of the installation or post installation would that actually be applied? And the reason why I ask that is that going to be counted as a substitute?
Well, I think it's the cost of going green. It's already more expensive to go green.
Yeah.
And it's going to be a lot more expensive to go green. The cement companies have already bought up the supplies of slag and fly ash, and guess what? The cost of those materials has increased.
Yep.
And then we've got concrete companies making their, enviro mixes and charging a premium for them because they're so special. They're actually cheaper to make, but they're charging a premium for them because they can.
The marketing's more expensive on that one.
Yeah. So eventually market forces will bring that cost back, but in the short term, you have to pay more to go green. So and I think having to use the densifier as part of normal process is a part of the cost of going green.
Okay. So I guess the question I'm asking is, you've changed two components there to that's a substitute material.
Yep.
And now we're introducing a densifier, so a third component. Would that be counted in the green contribution? as a substituted material.
Yes, potentially if we don't use a curing compound.
Okay.
And one of the problems with curing compounds is what about the VOCs?
Yeah.
Whereas the densifiers virtually got none.
Correct. So
potentially the densifier adds to that. But these are marginal points.
Yeah.
The bigger points are made on the whole building, on the steel and, everything else that goes into that project. So I can see there's a little bit of advantage, but I think our primary goal is to have floors that work.
Yeah. Yeah. Okay.
We got a green building council that says, well, we've got to do this, but they haven't told us how to do it. And so we're trying to work that out. And I keep reminding people that concrete's evolved over a couple of thousand years.
Yes.
And they want revolution. Then my understanding that when you have revolutions, there's usually blood spilled on the ground. And I'm just hoping that it's not yours or mine.
I don't want to be on one of these sites that you're working on, Peter.
Because the blood spilled on the ground will ultimately be somebody's dollars.
Yeah.
And there's potentially, quite serious costs to people who have attempted to do something that hasn't worked.
Yeah.
And history tells us that with concrete, particularly unformed surfaces, that you can go and build 20 or 30 of these thinking you've done a great job, and a year or two later you discover you did a bad job.
Yeah, well, that was going to be one of my other questions. I mean, like you said, this has been an evolution over thousands of years, and what we're trying to achieve in what seems like a relatively short time is quite a lot.
Yeah.
And how are we backing this up with data that, from a long-term perspective, we don't know?
We don't really know. We do know that the increases in supplementary materials do improve durability of the concrete overall. Mm-hmm. The particular marketplace that we're looking at is unformed surfaces.
Yeah.
The formed surfaces part, that's easy.
Yeah.
But the unformed surfaces is the issue because of the traffic issue that goes on them.
Mm-hmm.
And creating a dusty surface or a weak surface layer, it then costs money to fix it.
Yeah.
Because if you don't fix it, it'll wear irregularly, and then you'll have coarse aggregate popping out. So if you can grind it nice and flat, you change the paradigm of how the wheel wears the surface, and you can arrest that. You put a densifier on it, then you can tighten up the mortar sector of it and stop that from absorbing whatever's going to be a contaminant, and you can get back to a hard-wearing surface.
Sounds like a very good solution.
In fact, before we had the ability to do burnished finishes, back in the old days, they used to grind factory floors to make them hard-wearing.
Right.
Because they only had handrails to finish and it wasn't good enough. And so they used to grind it. And if you expose the coarse aggregate, you create all these little really hard, flat sectors that the loads get shared upon. And so exposed aggregate finishes are very hard wearing. And the wear that you might get from the mortar section is limited by the amount of contaminant that's on it.
Yep.
So if you keep the floor clean, the amount of contaminant doesn't really wear in between the coarse aggregates. A typical bluestone runs around 90 MPa.
Yeah, right.
So if you grind the top of it, you create a really hard,
absolutely
solid surface to work on.
Yeah.
But grinding all these factory floors costs a lot of money.
I think that's a necessary cost for going green, and we have to do it.
Yeah. So they're in, potentially bigger, faster trailing machines. Not trailing machines, I mean grinding machines.
Yes.
They might be part of a solution to do that. And then don't worry about finish. You just run a bull float over it, walk away, and let the grinding machine come in.
Okay, just edit that. We're not going to let that out. We don't want people to see an opportunity here to not finish the concrete properly. We've had 20 years of saying it's all right. They're going to grind it. The grinder will fix it.
Yeah. Well, look, I can see some enterprising contractors working out different ways of dealing with this problem.
Yep.
And I guess the other one, we're probably relying on cement companies, and we know that one cement company has already developed a lower carbon cement. But it's used a lot more limestone as a filler in order to create that. Now, the downside in your sector is that you'll probably get more efflorescence coming out of polished floors.
Yeah.
And so managing the efflorescence will be, one of your costs or one of your difficulties in going forward where the concrete's got more limestone in it.
Yeah.
Now, I'm not a cement chemist, so I don't know what the other opportunities are to replace cement itself within that matrix, but there might be things other than limestone. But right now, that's the one that's doable.
That's the solution. Yeah.
Yeah.
Okay.
So I know all the cement companies are working on how do we make a lower cement concrete.
Mm-hmm. How do we sell less product? How do we make something that we can't sell as much cement?
Well,
I don't see the motivation.
No, but there's a shortage of cement.
Yeah.
So it doesn't make any logic to be using more cement if you don't have to.
Yeah.
But to be able to create a lower carbon cement is certainly the logical way to go forward.
Mm-hmm.
And I think worldwide cement companies are trying to work that one out. They're all still consuming their clinker. So eventually, where does the clinker come from?
Yeah.
They're protecting their marketplace long term by doing that. And whoever comes out first will probably get a bigger market share than what they had before. Mm-hmm. So there is a bit of a race.
Yeah, right.
Which is probably healthy, and eventually that'll find some equilibrium.
Yeah.
What I don't see is the world stopping building structures.
Well,
I don't see that happening. I think we hopefully we will get to a position where we're building with more long-term endeavour in the structure that we do build.
Mm-hmm.
Not treating it like you're building your warehouse, 40-year life cycle, we'll bulldoze it in 40 years and we'll build another one.
And what do you see would change that type of attitude? I mean, that seems like the biggest opportunity to reduction.
It does. That's probably going to be stronger legislation to be able to do that. So right now, I think most governments are just sitting on the edge of what they can get away with. Mm-hmm. They're not thinking long term. They're just like, the rest of the world wants us to stop doing this. So
how long do most governments sit for?
And I'm only in here for 4 years. So
I was only hoping to be in this job for 4 years. How could you expect me to be thinking for the next 300 for the country?
Yeah, that's right. And so we live in a world where governments are reacting short term to everything. And part of this green movement really, I think, governments need to realise you can't think short term, you've got to think long term.
Mm-hmm.
The one thing we talked about was this absorption of carbon dioxide back into the concrete.
Yeah.
So concrete structures absorb carbon dioxide and it reacts with lime that's within the matrix, and it's called carbonation. So the reaction of carbon dioxide with lime is calcium carbonate, and that product is something that happens all the time. Now, if you had an external pavement and an internal floor,
mm-hmm.
the internal floor will probably have a greater rate of carbonation than what the external pavement does, because the external pavement keeps getting rain on it and it washes away the carbon dioxide. So you have this, you don't tend to absorb so deeply in an external as what you do on an internal, which is a dry environment.
Yeah, okay.
But walls have got air touching them. If they've got air touching them, they're absorbing carbon dioxide.
Right. So don't go plant trees. Build more concrete structures.
Or build more concrete and build the trees next door. Plant the trees next door. But I think what we're seeing at the moment is there's a reaction to let's not use as much cement.
Yep.
There's not a consideration. But
is anyone calculating this?
I don't think so.
Right. So there's a potential that we're actually absorbing a whole lot of carbon that we're not even calculating at this point in time.
Yes, there is. But I guess in history, remember how many trees we cut down? And they were making oxygen and taking in carbon dioxide. So a concrete structure is just becoming a static storage, and it's not absorbing as much as it made, but it is something that is happening. So concrete isn't necessarily the evil.
Yep.
But concrete is the most used building material, and if we don't use concrete, what are we going to use? We can keep growing trees and we can cut them down and we can build stuff, but we're back to you're not going to build skyscrapers. And now we're struggling for usable land to put more houses on.
Yeah, don't have the density.
The reality is we have to have high density structures.
Yeah.
So we can't go away from building multi-level. We can't just go and get rid of half the population. What are we going to do?
Mm-hmm.
So I still see concrete having a valid role, and the moves to get more supplementaries in, I think, are positive. They create opportunities for some. They create hardships for others.
Mm-hmm.
But the opportunities are to help out with the hardships.
Yeah.
So the use of the densifier, I'll get back on that. We have seen over the decades up to 30-40% replacement. One concrete supplier in Melbourne in the 80s and 90s regularly used 40% slag.
I think I know who they are.
The slag quality now is better than it was because it's ground finer.
Mm-hmm.
And the concreters don't like it because it takes too long to go off. And if you were using it for, let's say, post-tension slabs in multi-level buildings, you wouldn't be able to stress this early. So you've got a program issue that goes with that. But most of the concreters have been using 10, 15, 20% for a long time.
Mm-hmm.
The two big industrial concreters in Melbourne have used somewhere between 10 and 20% for, a decade or more.
Yeah.
So that's not new. They were happy to use 30% in the summer because it slows down the concrete.
Yeah, of course.
They don't want to use 30% in the winter because now you've got to pay for accelerator or hot water. So that's the first issue for them. Their costs go up because they got to do that. I see the durability of the surface above 30% is potentially at risk because it's very difficult to get enough moisture retention in that surface layer, particularly on external pavement. I recently looked at a job in Brisbane that used 35% replacement, and I was able to scratch through the burnish layer with a nail.
Wow. How long after installation?
It was... Yeah, I don't know exactly, but it was between 2 and 4 weeks when I saw it.
Right.
And the contractor has been doing Mo's scratch testing on it in the last week, and they've been struggling to get it above 7. Now, quartz, which is the biggest contaminant through sand, that's 7. So the surface needs to be higher than 7 to be not readily worn away by the contaminant. So 7's not a good answer for a warehouse wall.
Yeah.
And that's what I see. So I'm looking at it and I'm thinking these guys need to put a densifier on it, but they've already put a curing compound on it. And now they have to remove the curing compound in order to put the densifier on.
Yeah. It's almost defeating the purpose, isn't it? And we're talking about warehouse floors. This is really large volumes of concrete that's going in. We can't really afford to make mistakes on those types of volumes just for the sake of doing an experiment to find out.
Correct.
Because it really defeats the whole purpose of what we're setting out to achieve.
Well, this warehouse I'm talking about is 10,000 cubic metres of concrete.
Wow.
And
it's a small experiment.
Yeah. And so that's there's a lot of space there to now grind off the surface.
Well, I'll get you details after this.
To put the densifier on it, or grind or scrub. Either way, it's going to cost a lot of money to get the curing compound off.
Yeah, and then
depending on the type of curing compound, it might have absorbed in, so you've got to grind a little bit of the surface away. So the smarter way for me is to be thinking about using the densifier as part of the finishing aid.
Yeah.
And then doing the curing with the densifier and putting it on straight away.
Yeah, we're killing two birds with one stone in the process side of things, but we're also reducing the, what we're actually applying, as well, because we've removed the necessity for the curing compound. Which we're potentially talking about having to then bring something else in to remove that. That's just throwing away product that we've had to bring to site, something that we've had to produce. So that's also got some impact with it as well.
So, without mentioning company names, 2 years ago we were involved with a big box retailer, and they were water curing their slabs and then later on putting a densifier on. And the problem with water curing is that you get a lot of lime efflorescing out in the water, and when you remove the water, then that residual lime will it'll precipitate, it'll get reabsorbed into the surface. It'll then very quickly react with carbon dioxide from the air, and you get calcium carbonate staining in the concrete. Now, to get rid of the calcium carbonate, you've either got to grind it off or you've got to use an acid. We don't want to put an acid on the concrete because it will retch in the surface. So that was a big problem for this particular retailer. And by the time they got their densifier on it, they had all this heartache of calcium carbonate staining to get rid of. So we suggested to them that whilst this doesn't comply with the concrete code, AS 3600 for curing, is that it was possible to prove that the strength could be made in the slab if we did some core testing on a trial. So we did a trial. They did a 100 square metre trial slab, cured some of it with curing compound, cured some of it with this particular densifier that you could put on the same day, and didn't cure any of it, which is what we call air curing. And we got cores extracted, and the core samples proved that the densifier version had actually got higher strength than the other two and was of a higher strength than the design required. And the engineer accepted that as the method of curing for that project. So that big box has done 2 projects in that curing that method. They've also done a warehouse in Sydney that used that method of curing, and they're scheduling to build one in Melbourne where they're going to use that method of curing. So that's worked out quite positive for them, and they actually saved money because they took away the water curing. They took away all of the risk they had on calcium carbonate staining, and now just use the densifier and getting a really good result on the hardness of the surface.
I'd imagine.
Yeah. So I'm looking at the moment, I'm talking to concreters about it, and it's like, oh no, the densifier costs too much. But if you delete the curing compound from that process, you delete the having to clean it off later on as part of that process, then the method of curing with the densifier is also picking up the hardness and durability.
Yeah.
So I see an opportunity for a smart manufacturer of densifiers to target what's required for high SCM concrete.
Okay, well, that's going to be the next hard part, is finding that smart densifier manufacturer.
Yeah. I wonder.
I'm just taking notes. I'm just writing that down. But I mean, it sounds like obviously it's a good opportunity, but it also sounds like a really positive direction to be taking anyhow. Because you're ticking so many boxes here, and I could imagine that the concreters would look at that price to begin with and go, oh, that's more expensive. But like you say, you're not applying the curing compounds. You don't have the labour tied up for that. Yeah. You don't have the labour tied up for trying to manage the calcium carbonate.
Yeah.
We're doing okay now.
Yeah.
When we look at the full picture.
Yeah. I guess people ask me about calcium carbonate staining all the time, and if you've used the curing compound on the floor, you don't get it because the curing compound's preventing the air from getting in touch, and the air fluorescence is not really coming out because the moisture is coming out quite slow. So you get this separation. But if you've water cured, you're actually quite open to it.
Yeah.
And I also remember, particularly when I was still consulting on the Bunnings projects, is that if you had a leak in the roof and the water drops on the floor, no one bothers to clean it up, and they allow it to evaporate and wonder why there's this big white circle on the floor. And so if you have a water spill on the floor, you've got to clean off the water. You can't allow it to dry by itself or you'll get more efflorescence. And if you get efflorescence, you're at risk of getting calcium carbonate.
Yep.
So cleaning off the water is a big deal.
So as far as calcium carbonate, is that only an issue from an aesthetic point of view?
Yes.
Yep. Okay.
Yeah.
That's all that we're trying to mitigate here.
Yeah, because the floor looks dirty. If it's got patches of of this lime colour all over it, it looks dirty. And, your best friend comes in and thinks that you're not looking after you don't clean the place very well. Yeah, but in terms of a retailer, it's the floor is really important to a retailer because it says a lot about their business. And if it doesn't look really nice, that's not a good image. And we find with the owners of industrial buildings, they also like the floor to look really, really good because it affects the value of the rent that a customer is going to pay.
I did not realise that.
Yes, and therefore it affects the value of the building.
Mm-hmm.
So for them, a good-looking floor is really important.
Yeah, okay, right.
It's not just about function; it is also about aesthetics.
Mm-hmm. Sounds like you've been around the traps, to know where the biggest levers are on the projects.
And as I said previously to you about the concreters that do the industrial work, they're also attuned to you can't have these visual defects. You will be criticised, and they don't like that. They want to leave that project with everybody having a good feeling about it and having a good feeling themselves. So that's pretty important to them to get that right. Just a little aside, sorry about that.
That's all right.
You asked me some other questions here before. You asked me a question earlier about how qualified are the people that are nominating how we do this. And I think not very, because they also have created some targets at which the cement content should be reduced from. Mm-hmm. Well, those targets they must be using very weak cement as their base,
right?
Because those targets are way higher. So I think that ties back into how do you reduce the carbon content of building is, well, if everybody only used as much cement as they needed and did a little more QA testing on the way through, they wouldn't need to fatten it up and create this sense of security that their mixes are always going to go high on strength. So there's a lot to be gained by not just cutting back cement contents. So most often, for an example, you can make 40 MPa concrete with around about 360 kilos of binder.
Yep.
And we are frequently seeing mixed designs more than 400 kilos. And so what the suppliers have really done is they've shifted their standard deviation above the strength target, completely above the strength target, not either side of it. And they're just targeting higher strength
to avoid litigation, right?
Yeah, to avoid issues that they get from having low strengths.
Yeah,
but that's not part of where we need to go. We need to stop using so much cement, and so getting those Green Star points could be achieved more easily if the concrete suppliers cut back on the amount of cement they use.
Yeah, okay.
And if you cut back on the amount of cement you use, then under the current rules, you don't need to use as much supplementary.
Well, that makes sense in theory because you're cutting down on the cement, but you're talking about the current rule is you've got to have 20% supplementary. Well, what about if I reduce the actual cement that's in there? Do I still have to come with a 20% supplementary?
All right. So the bigger picture here is what we need to be looking at is what is the quantified number for embedded carbon that you're trying to eliminate? And that's not the number that's getting pushed out from the Green Building Council. What we really want to see is what those embedded carbon numbers are, because every concrete supplier will have a different carbon number for whatever that percentage reduction is.
Yeah.
So there's one supplier in Melbourne right now who can use their low carbon cement and maybe not even have to use supplementary and still meet those requirements. But the ruling coming down is, you've got to meet 20%, but 20% what?
Yeah.
So 20% doesn't make any sense.
No.
And when we talk to some of these consultants, we're not getting any conclusive information out of them. They're just reading the book.
Yeah.
So we see a lack of imagination. Maybe that's not the right word, but there's a lack of endeavour into work out a better solution and just take the easy one that's written down on the paper.
Yeah.
And concreters in this country have been using curing compound for a long time because of the way it was written down on the paper.
Yeah,
not because it was doing the right job.
That's right. Yeah. And I guess you often have that with any type of standards that you put in. That becomes the minimum standard, not the maximum.
Yeah.
So I guess my other question would be, we're getting told that these are the minimum requirements that we need to hit. I'm assuming that there's no incentives there to exceed that.
No, I don't believe there is. I don't know enough about it.
Yep.
I was hoping that I could get to retirement before I really had to worry about it, but it's catching up a bit quicker. And so we do have some concreters who are doing trials.
Yep.
In a typical warehouse, there's a forklift recharge area that's going to get ground and have an epoxy coating on it. So that location is a perfect example to do some trials.
Yep.
And so you can pour, 4 different truckloads, 4 different mixes, judge how well you got your finish on it or not, and then potentially do some abrasion testing on the surface to see whether it was durable enough. Or if it's not, what do you have to do about it? And in those locations, you're going to grind them anyway. We know there's concrete underneath will have made strength because the concrete supplier's already proven that.
Yeah.
The whole issue is about what we can achieve at the surface, not anything else. The rest of it works.
Yeah.
Columns, beams, walls, it's just a matter of how long did it take to make the strength. I can see precast concrete will struggle a little because those guys are trying to pour a panel this afternoon and lift it tomorrow morning in order to utilise their table again. So they might struggle a little in order to be able to lift it. They have to change their table setups. Maybe they need to do tilting up tables so they don't have to stress the panel so much in order to lift it. But I think they've got a bit more work to do to be able to accommodate it. But if you think about how much concrete goes in the walls on any one of these buildings,
absolutely,
it's a big contributor.
Yeah, it's a big contributor, and then you've really got to be pretty sure on your numbers what they're going to stack up as, because you've got to be the first guy to do it. Because if you look at it just on base numbers, you'd be thinking that's going to cost a lot of money to change the way that we're working.
But the first guy to do it can run around selling his services as having the greenest concrete. Yeah. So I'd like to see one of them take the challenge and get on with it. Yeah. That potentially makes a lot of difference. Oh, and you can polish concrete walls too,
Yeah, you can. I prefer to do it, before they get tilted. But
it's still possible. All right.
Yeah. Yeah.
Cost is still. It's still going to cost more to go that way. Now, in terms of evolution, that cost will eventually come out of it somewhere. But you're starting off something new. If the objective is cut that back, then deal with the hardships, most likely through cost, in order to achieve the original goal. When you've achieved the original goal, then work out how do you save the money.
Or how do you increase the margin with the savings?
Yeah. Or how do you increase it? Yeah. But it's like I'm in the problem-solving business, and what I find is that people don't want to be part of the problem-solving because this takes more time, or I need more men, or I need more materials. This is going to cost me more. Yes. And if you use cost it'll always be a handbrake. And you've got to accept that you're not going to be subjected to that extra time and cost forever. You're only subjected until you learn how to do it better.
Yeah, correct.
And then when you've learned, then you can focus on how do I now, I've resolved how to do it. Now how do I do it better so that I don't suffer the cost? Yeah. So there's an emotional thing to jump over. I know I'm spending more money. It's coming out of my margin, but eventually it'll be good for me. Yeah. So the one that does it first will be the one who can go and market a green floor. Yeah. And sell that to the marketplace.
They reap the benefits first.
Eventually.
If it's the right solution.
Yeah. Well, I think, and I'm seeing this, the industrial guys at the moment, some of them are spending some money, but they realise that they need to spend it and do the development work, because in 12 months' time they might be getting slapped in the face. So they're doing the work ahead.
When you say slapped in the face, what are some
in terms of do it now?
Yeah, okay, gotcha. Yeah, learn now. It's going to be the most expensive time to learn.
Eventually you're going to be do it now, and you walk into it not knowing what you're going to do or how you're going to do it.
How much of the market would you say that's going to be that's going to be slapped with it?
Well, there's about 6 industrial concreters in Melbourne, and I know 2 of them are working on it.
Yeah.
I don't know that the others are.
Yeah, okay. It's a good chunk.
Yeah. When I say industrial, the high-profile ones that I get to see, they're doing. No, I'll tell a lie. There's three working on it, and trying to work out how to achieve it, how to first of all how to finish the concrete, and secondly how to get the durability in that concrete, and also discovering what defects we might be getting on the way through, and are those defects manageable? Are those defects things that we can cut out by changing the process slightly? It's a bit like driving a car. There's an infinite number of ways you can steer that wheel.
Yep.
There's an infinite number of ways that you can apply your trailing machines. One of them might be steel pans are not the answer. Maybe we need to use plastic pans, or what combination or what material of plastic do we use? So there's little things, subtleties like that to change that paradigm on how to finish it.
Yeah.
Essentially, I don't see the fact that we need a machine that turns clockwise and anti-clockwise is going to change, but the way we apply the machine is likely to change. So these guys need to work out how to. They've adapted by changing from reinforced concrete to steel fibre reinforced concrete. They've already made that adaptation, and so this is the next version of adaptation, I think.
Yeah, okay, right. You get to see a lot, Peter.
I do.
You get to see a lot. What do you prefer to? I'm assuming that you prefer to be called in to try and work out these solutions ahead of time, as opposed to.
Most definitely. I make more money out of the problems, but it's much more satisfying to be at the start.
Yeah,
and to help everybody get to a better outcome. And for me, part of what I do is try to get in between all of the players and get rid of the conflict.
Yeah.
Because construction is an adversarial industry, and it's usually the person who's screaming the loudest is usually the one who doesn't understand what everybody's going through.
Yeah.
And so if you can help make everybody else understand the other guy's position from what me as an independent, unbiased position, then I'm more likely to get the harmony in the job and get everybody moving forward to what they want to do.
Yeah. That's when you get results, isn't it?
Yeah. And move away from the attitude of the one party trying to get their pound of flesh out of the next party. And say, well, don't count other people's money, just look after your own. And this is what we can do to make your patch a little bit easier, and at the same time we can make that guy's patch a little easier by doing it this way. Yeah. So upfront's better. We get less defects. I don't earn as much money, but I don't have problems sleeping at night. Indeed, in disputes, no one sleeps.
Yeah. No, it's a good point, I think. Yeah, it's a good point.
Yeah. I do have an attitude of being pretty hard, and I'm quite direct because I don't like beating around the bush. These are technical discussions.
Yeah, not
beating
emotional.
Around the bush doesn't work. You need to be precise about what you're talking about. And it would be true that I don't suffer fools very well, and I just want to get straight line. That's always been my attitude. What's the problem? What problem are we trying to solve, and what outcome are we trying to get to?
Yeah.
And I think if you can just follow your way through and try to stay away from the emotion, life's easier.
Yeah.
My wife can't believe I said that. Stay away from the emotion. Yeah. But look, I have been a builder, I have been a concrete supplier, and I have been a concrete subcontractor. So I understand how everybody counts their gold.
Yep.
And that's just trying for me. I just want everybody to be able to count the gold that they thought they were going to get.
Yeah, and I think that's a pretty good approach to this in particular when you were talking about drastic amount of change in a short period of time is what we're looking at.
Yeah.
I think that's a very good attitude to be approaching it with if we're if we're going to have any likelihood of success meeting these targets and everyone coming through, surviving out the other end, but not just surviving, but succeeding.
Yeah. I think there's an opportunity for innovation, and I think if your customers are out grinding things and they're not quite working out as the way they want, stick at it and try different things, but make a record of it.
Yeah.
Don't leave it go, and because it's easy to forget what you did on that last job, but write it down.
Yeah.
And write your thoughts down. Maybe make a journal, because we really are at this time of it's not going to be the same as it was last year.
Yeah, I strongly believe that.
Yeah. And so the learning opportunities are huge. And when they're frustrated, tearing out their hair because they feel like they're losing money, try to get the perspective of whatever's going wrong, they've got to finish this job.
Yeah. Yeah. And not only that, we've got to get the most amount of value out of this experience. I'm pulling my hair out right now. I don't know what it is, but this is the things that I do know.
Yeah.
So that goes back to recording everything that you've got there, so that you can actually use that for development on the solution. Otherwise, you're just throwing away all the value from the job because you just want to get away from it.
Correct. So I'll give you an example of what I did. Some years ago, Bunnings went into this procedure where they were doing a high polish on all their warehouse floors.
Yeah.
And what we noticed was that the ugly work on the edges where the hand trailing had been done, they were even uglier. So when you polished it, you highlighted the defects that were there.
Yeah.
And so it drove me to think about, how do I get rid of that hand trailing work on the edge? And so I got more focused on, well, what if we re-screed the edges and use a short hand screw to screed the edges a lot harder?
Mm-hmm.
And then we don't have to do that hand trail work. And so then what if we then rely on the trailing machine? So we've already set edge formwork up that allows us to overlap the edge with the trailing machine. So now if I re-level those edges and make sure I cut the excess concrete away, I'm going to maximise what the trailing machine does. And then I realised that you actually need to have the joint edge taper away from the edge formwork a little bit. So over 900 millimetres, I now want the guys to lose a millimetre. I want minus a millimetre, 900 away from the edge, and make that a straight plane all the way up to the edge. Because then when the trailing machine comes through, the whole rotor now is in full contact with that plane. Mm-hmm. And that means when I have finishing blades on, all of the edges of finishing blades are touching all of the concrete.
Yeah.
So when you see lighter coloured edges or lighter bits on the edges, that was where the blade didn't have full contact and full pressure with that surface. So now we've created a scenario where the trowel blade has full contact and full pressure, and I'll get consistent colour. And then because it tapered away a little bit, when I do the edge on the other side of the joint and you overlap, then the tips of the blades are not touching the first side, they're actually in the air. So I'm not scratching the first side. And that was how I got rid of the ugly edges. So that was just that little bit of innovation to think the way through.
Yeah.
I've got a problem. What process caused it? How do I get rid of it?
Mm-hmm. Yeah. And the downside to that is because those ugly edges aren't there anymore, no one can appreciate what you achieved.
I know.
Peter, thanks for joining us today. A massive wealth of information that you've shared with us. Hopefully that's practical for a lot of our listeners. And again, thank you very much for your time.
Oh, thank you. And if I've helped one of your customers, then I'm a happy man.
All right. If you've been helped, you better let us know because we want Peter to be happy.
All right then. Thanks, Josh.
Cheers.
This show is proudly supported by Works Plus. Works Plus brings total solutions to all concrete grinding and polishing contractors to make it totally work for them in their operations. We hope you've enjoyed this episode. Make sure to tune in each week where we're going to dive deep into all things related to concrete grinding and polishing. We're here to help you so that you can boost your outcomes on the floor.